Hey, just don't listen to what I'm saying. I'm just going to do the tutorial for an aqueous simulation, and it's for a simple one-level steady model with irregular boundaries. Okay. The first thing is to go to the model input, then go to general, and you just define your units here. Let's do meter and time unit in day, and comments just call it a tutorial. Okay, then hit enter. And the next thing we want to do is to create a domain. Oh well, let's save it first. Save as, say, YouTube 2. The last video didn't work that well. Okay. uh, Model input, then domains. We want to create an unconfined domain, so click on that. So now it's data for unconfined domain. You can enter data. Let's do all, and level 1, and bottom 82. Average head is 109 feet. 109. These are important meters. Porosity 0.11. Specific yield is zero point 0.1. That's fine. K1 3, K2 is zero point 0.6. Angle between the two directions is 30, and the K3 at the K3 vertical top half is zero point 0.1. K3 in the bottom half is zero point 0.1, and rest is just fine. Hit enter, and you have the data. The, the model in the tutorial, it's got another research basin. It's a small area within our model. We're going to create another little domain within the main domain. It's called research basin, and it still will be in the level 1, and we'll keep everything just the same, 82. But it's because it's a higher research area, our head is a little bit higher, 115. I'm gonna keep everything else just the same. 0.6, still 30, 0.1, 3. All right. Okay, now if you have a base map or something that you can use, um, that would be really nice for the next step. Okay, for this one, um, this is what we. Okay, to select my base map, I go to plot input, then what to plot. Then on window, you don't put anything. On base map, I'm just going to use gray, and I already have a DXF file for the base map. I'm going to open that, and I'm not going to do anything else for now. Just hit enter. Okay, then if you go to your switch view and then do zoom all, should be here, but it's not. Let me do something and come back. Well, what I had to do, I had to go back to the plot input and what to plot and check all of those buttons here, and then go to my switch view window, and I clicked on zoom window to get this. This is my DXF file. So you can see I have the aquifer boundary defined as like irregular boundary right here, and this is a lake boundary, which is a constant head boundary, and around this boundary over here we're going to assume that it's no flow boundary, so there is nothing coming in or going out. Okay. For some reason, to to make the model work, you have to draw your aquifer boundaries. When you're digitizing, you have to start from the farthest right corner and go anti-clockwise. Wherever you start, you just go anti-clockwise to define your no flow boundary. For other kinds of boundary, you can go the clockwise way, but just to keep everything simple, I'm going to draw and digitize everything on a anti-clockwise pattern to be consistent. Okay, the first thing I'm going to do is to digitize the lake boundary. To do that, you come over here, and in the switch view window, if you can click on that to go back and forth between the two different view. You just go to the digitize and then do the polyline command on it, and then you just start, kind of just follow the lines, and there we go, and hit enter, and it says you have digitized the polyline with 4 vertices. The coordinates are in the system clipboard and may be pasted in your input for coordinates or into a word processor for examination. You just hit OK, and because you have a line already defined for the this is a constant height boundary, I'm going to go to the model input and go to line boundaries and go to let's see, head specify. Yeah, in this one let's call it lake, and then it's all domain. Don't worry about this 3 right now, and h start is 104, h end is 104. It's a constant head boundaries, and when you do to the next column, just asking you for the coordinates, you just paste it and hit OK. So now then hit enter. Always remember to hit enter. Okay, next I'm going to digitize this aquifer boundary, and I'm just going to start here and just follow these lines one more time. This, there, 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 there. I'm not trying to be like super accurate with these boundaries. They're kind of arbitrary anyway. Then hit enter. I have the same thing again. Now I go back to model input. Now this time my boundary condition is a normal flux specified, and I'm gonna call this one impermeable boundary. Impermeable, and domain, it's all of my domain. Normal flux, because it's impermeable, it's 0. Flow is coming in and going out. And then I paste this everything. When I digitized it, it picked up all those points, all the vertices. Now I just got to make sure that this, the first one and the last one, matches with my lake top and bottom, so that it's a closed boundary all the way around. Okay, to do that, we started with this, so let's copy this. What I'm gonna do, I'm gonna go back to my line boundaries and then to head specifier and look at so this, I'm going to change that to be this exactly, and copy this, and again go back to my line boundaries and normal flux specified, then the last one I'm gonna make this and hit OK. Now if I let's save it. Now if I do the switch view, and then right now if it's green, that means you already have the data assigned. If it's yellow, you still don't have the data assigned. And now if you do the make plot and make model input and just do all levels, if it's got any data, it should turn into green, but it did something that I don't know. So hold on, let me come back. No, it actually did, and if you go and take a look, you now know that this is actually a closed boundary, and I have my model defined. One side, the right side, is the constant height boundary, and the rest is impermeable boundary. But we still have two more things to do. We have a river going through this model, and we have a well. Now let's work on those next. Okay, what I did, I digitized this stream, and if you go, what I did, if line boundaries and then river, it's a river, you have all kinds of different parameters, and they're all in the tutorial. And I'm going back to the switch view, so all this is now defined. So now we have to define a recharge zone, and we want to separate that from our model boundary. To do that, we gotta go to the model input again, then line boundaries, then inter-domain boundaries. So within your domain, you're creating a smaller domain where your properties are going to be different. So you click on that and just call it, say, Richard Basin, and it says domains left and domains right. So you just pick up OK. Okay, we have defined the reset boundary as a interdomain lines now. And if you go to the switch view, and this is my interdomain boundary right there, and do the make plot again. Now see, everything is now in green. That means everything got some kind of data. Next we specified the well. You just have to go to model input again and do the pumping well, and I'm doing a discharge specified here. So domain all is going through all, so through the unconfined domain, and I have selected a point. Radius is 0.2, discharge is minus 414. Now you need some research to your boundary to your model, and to do that again I'm going to model input, add source and sink, then uniform domain, and I'm for the all uh, top flex I'm going to use 0.0006, and the bottom we're just not going to use anything. And from recharge basin, because we are saying it's a recharge area, we're going to use a little bit higher number here. And again, the bottom is not uh, 0. Well, your model is now ready. We have defined our head constant head boundary here, our impermeable boundary right over there, our river, our well, and we have defined our recharge to our model too. So now we can solve, and to do that you just go to the solve and just hit solve. And solve process time because terminal elements are outside the boundary of the other domain. So there is something wrong. So let me stop. Okay guys, I made a mistake when defining my interdomain boundary. Your domain's left gotta be the recharge basin, and domain right gotta be the all. And now you have your model ready. Now you can click and analyze and check boundary conditions, and it will check everything. And now to solve your problem, just hit solve, and it will say it took 5 iterations to do it. It's converts with the specific solution check values, and the solve is completed. The next thing we're gonna check is go to the analyze tab over here, and we have a discharge specified well. So I'm gonna click that and see. So it's saying heads at discharge specified well would be 98.49, that many meters. And you can do other things too. Go to analyze, and we have the river boundary. So let's check what's going on. And discharge of the river boundaries, it also giving me it's 300 minus 358, 260, and 313. Now you want to plot and see how your model looks like. The most of the time we would like to see the head. To do that, we go to the plot input and go to the contour setting. And if you use a -1 or -1, then it will already define your contour so that you have only 25 contours, so it will divide your contour intervals that way. So that's pretty good. And you can also go to the vector setting and use something like vector 600 points and say scale factor is 2. Now to view this, let's save it real quick and go to the make plot, and everything is going on at level 1, so I'll click on level 1, and aha, I have got my really nice head distribution and all the flow vectors and everything. Don't you like it? Well, that's it guys, and you have now generated your model, and you can play around with some of the buttons over here. And what I did in here, I actually went back to my plot input. Then on the contour setting, I changed my points to evaluate to 40,000 and my increment to 0.5. What it did, now I have my contours which are a little bit more smoother, and I have a zero point 0.5 increment, and they're all good numbers, 120, 120.5, so 121, 122, stuff like that. Well, you can do a few more things with this now. You can see how effective, how good your model is, and you can change. You can look at the view manager. You can freeze your base map and change the colors of your domain, stuff like that. But I would encourage everybody to go back to the AnAqSIM and then just go to the help menu, and you You just come to the model input menu and you can go through the same uh, exercise that I have just been